Okay, 4-4 yesterday. At the end of the lesson, we were talking about variations. Remember, I can't talk. Between positive or negative, right? Okay, I went and looked at the homework. It is not in the homework, so it is not on the test. So the variations slides at the end of 4-4 you can disregard if you want to. I also kind of thought it was a little too easy. It's kind of silly. Because I know you'd be like, well, can we have a whole test on that if it's easy? But it's not on there. Okay, 4-6 is short, sweet, to the point. We're going to do 4-6 right now. And then we're going to do 4-5 after y'all go to lunch and come back to me for class. Remember, we have 4 days of hard work, so you can have a week off, right? So get disciplined, stay focused, and get your homework assignments done by Friday. I'll extend, what is it, 4-3 and 4? I'll put the due dates for the 4-3, 4, 5, and 6 homeworks to Friday so that you can work on them without worrying about the 90. Only 3, 4, 5, and 6. 4, 1, and 2 should be done.
Pierce.
4-2 is almost done.
Okay. All right. Good news about 4-6. It covers 2 topics. There's no word problems. It's just 2 topics. I don't know why, but rational inequalities is not on the generated exam, and it is not on the final exam. So I'm trimming that fat, and we will not be doing those slides in these notes. We will only do the first topic, which is polynomial inequalities. Okay, so
No.
we're skipping around. 4-5 takes 2 days. We're gonna cover it in class today, and then what we don't finish tomorrow / review. Okay. Oh, I know. Well, it's driving me nuts. All right. Look at this. Okay. Am I done? What is different here? Look at the example. What's new? It's an inequality. We still have polynomials, but now you have an inequality sign in here. Notice it's no longer an equal sign. It's an inequality sign. I personally find these easier than the equality, like the equations. With the equations, you have to do that rational root theorem, P's and Q's, find one that works, plug it in, go to 0. Just started. We're on the 4-6 packet from Thursday, last week, Friday, whenever I handed it to y'all. I find these easier than equations because you don't have to do rational root theorem. You don't have to do synthetic division and all that. This is, in this case, this is a quadratic, and it's saying solve the quadratic when it's greater than 0. Okay, let me give you a preview of what's to come. In terms of the graph, the quadratic is greater than 0 when it is above the x-axis. It's a simple, like, where is the graph greater than 0? That one didn't highlight good. It's this way and this way. Now, in terms of actually answering the question, you would have to translate that to say, okay, so it's all of these x values and all of these x values. Now, let me make sure you understand that, because this is the end game. I'm fixing to show you the math behind it. The graph is above 0, where I have it highlighted in green. It's hard to tell from that, but that graph is doing what? It's going out. So what x values is it covering? It's covering this direction and this direction with arrows. And then because it's greater than only, it would be open, open.
So we're going to be using hammer notation.
Yes. All right, now let me show you how to do it algebraically. Let's take some notes. Where is the graph? That's all you have to ask yourself. And then, of course, it does matter, you know, what the inequality says. In this case, it's where is it above the x-axis?
So whatever it's n equal to is the y value, like how 0.
Yeah,
So if that
because
was
it's the
5,
same thing as solving for the solutions, but since it's in an inequality, we're no longer interested in just where it crosses the x. We're interested in where we shade on the x. Now, how do you solve it algebraically? You pretend like it's an equation. Pretend like it's an equation so that you can find where it actually is crossing the x-axis, which means your critical values. This will factors of -5 that add up to -4, -5, sorry,
and 1.
and +1. Since a is 1, I can go straight to parentheses, x minus 5, x plus 1. Pull the zeros out. What 0 comes out of this one? What about this one? Okay. Now, I like to draw the number line. You don't have to, but I like to do a number line, plot my numbers, and then I test my points. Well, if I already have the graph, you know, like I've graphed it, I've done in my calculator, I can see the graph, then I can already see where this is going to be above, right? But you could come here and plot your points, -1, 5. Don't forget to pay attention to open or closed. Open, open. How do I know where to shade? You know it's going to be on the outside, but if you're worried you've done that wrong, test a point. I like to test 0. You're going to test 0 by plugging it into the original. If I plug it into the original up here, this would be gone, gone, and you would say to yourself, is -5 greater than 0? No, which means don't shade where 0 was because it came to be false. I'm going to put an X there like this was false, which means these have to be true because it alternates, unless it's sitting on it, which we're going to do one of those. I'm going to show you where it's sitting on it. But you should know it's not sitting on it because you would have previewed the graph in your calculator to get an idea, okay, where's it above? It's going above on the outer regions.
The one with some graph. The big X, -5, -5, and -1 instead of -4.
Thank you. When I wrote -5 and +1, I'm like, wait a minute, I don't get it.
Because you had the
Yeah.
-1.
But I'm like, nobody's stopping me. Thank you. That was a housekeeping detail. I didn't finish it. Notice how this matches this. They should match. That's why I like looking at the graph, because then I kind of get an idea of where my final answer is going to go. Now, in terms of my math lab, they do want interval notation. So put your infinities here so you don't write this wrong. Read it like a book, left to right. So -infinity up to -1, union 5 to infinity. And beyond. Alright, that's it. Now let's just practice. Let's try one where we get shaded in the middle. So go to the next one. You will notice on the next one, there's stuff on the other side. What do you need to do to it? Yeah, you need to bring it over. You need it to be something with 0 in order to start the process of solving it. Alright, so I'm going to subtract this under its like term, and in this case, subtract that under its like term. I also like to be able to have the polynomial on the left, the 0 on the right, because then I'm saying to myself, where is this graph, read it like a book, less than or equal to the x-axis, right? Where's the graph less than or equal to the x-axis? So, you could go to your y equals and type it in and kind of get an idea of what your answer is going to look like. So okay, if your plot is on, go up there and turn it off. So we've got x squared plus 2x minus 8. And I'm just going to do zoom 6. So, where is the graph less than or equal to? Less than or equal to, meaning underneath. Now, what x values is that between? Here to here. So we're going to have one shaded section, and it's going to be in between two numbers. Do you see how that kind of sets me up to be able to answer the problem?
Yes.
All right, so now let's do it algebraically. Okay, that is a quadratic factors. Factors of -8 that add up to 2. Very good. Because A is 1, please don't jump when A is 1 if A is not 1. You know what I mean? Like, remember, A is 1 is when you can go straight to parentheses and be done with it. If A is not 1, you would go to the parentheses, plug it in, but then one of them would reduce. So please remember that. And we're treating this like an equation right here. So I'm going to draw like a dotted equal sign. Because we're trying to just find our critical values. What's the 0 out of this one? -4. What about this one? Remember, you get those by setting them equal to 0 and solving. All right? Draw a number line. Plot. Look back at the original to know if it's open or closed. It's closed because it's or equal to. We already checked this in our calculator. We should be shading in the middle, test 0. The only time you can't test 0 is if it was one of them, the critical values. We can test 0. It's about right here, right? If I plug 0 into the, you can plug it in the original if you want. I like to plug it in the one that has less to do. I get -8 is less than or equal to 0. Is that true or false?
True.
That's true, which means I am shading in there. You need to take some notes. We're going to test x equals 0. And it gave us -8 is less than or equal to 0, which is true. Now, to write your answer as an actual interval notation, it is sandwiched between -4 to 2 with brackets. Okay, I'm going to leave, bless you, I'm going to leave, no, go to the next slide. You will notice it's the same polynomial. Notice it's the exact same polynomial that we just did, right? The way that we did it was we moved everything to one side, we put it in the calculator, checked the picture, then we solved it algebraically. There's a second technique. If you just want to, if you're worried that you're going to do that wrong, you could plug the left side in Y1 and the right side in Y2, and you could check to see where is your Y1 graph, you have to know the colors here, less than your Y2 graph. So if you look at this picture, Y1 is a quadratic, Y2 is linear. Where is the quadratic underneath the line? Lower than the line, less than. It's less than here. Now look at the x values. That would be here to about right there. I can't tell exactly. But it's the same thing we got. We got -4 to what, 2? Yeah. Do you see that? So that's the second approach. I personally don't like that approach. I just like to say, get it all to one side. Where is it, above or underneath the x-axis? But that's a different approach where you're just comparing the two graphs instead, individually. But it's the same concept. Where is one higher than the other or lower than the other? Okay, let's do this one. We have x cubed minus x is greater than 0. Okay, you would go to your graphing calculator. You would type the left in y1. You would hit zoom 6. You're going to get a cubic Saturday Night Fever curve, right? Then you're going to go back up here and you're going to say to yourself, you know, what is it asking me? It's saying, where is the graph greater than the x-axis? Meaning, where's the graph above the x-axis? I got 5 minutes. Perfect timing. It is above the x-axis right here and here. Now, in terms of the actual answer, you have to look at the x-axis. So it's between here, here, then here to infinity.
Ooh.
So we're going to have two sections, and one of them is going to have an infinity. You with me? So I love this because it's like a preview of where you should have your answer. Okay? Now, how do we actually solve it, though, algebraically? This one's a little different. That's why we're practicing these. You have two terms, but one of them's a cubic. What do you notice about the two terms? They both have a GCF of x. Anytime you have two terms, one, check if it's a difference of squares. It's not. Two, check for a GCF. There is a GCF of x. Pull it to the front. By all means, don't throw it away. X is a solution. You can't just let it disappear.
X plus 1, X minus 1.
And 0. So it's a cubic, which means you could have up to 3 answers. You just pull the GCF to the front. Don't get confused. You now have...
At this time, if you attend afternoon classes at the Career Academy, if your bus is here, you may come to the front area for loading. Again, any students who attend the afternoon classes at the Career Academy, please report immediately to the front area for loading.
10 weeks of school. If these kids don't know when that bus gets here, they should not be allowed to go. Anyways, you have something times something equals 0. So set each of them equal to 0 and solve. Now that one's done, right? That, now you can see why we couldn't just let it go away. 0 is a solution for a critical value. Now this has only the x squared term, so solve it by square roots, right? Don't forget there's a positive or negative right there, because that's a whole nother answer. All right, we've got -1, 0, 1. Open or closed? Open. We already know where to highlight, but if you need help, just pick a number and plug it in. Okay? I would probably pick, well, in this case, you can see that it clearly, like it's below, above, which means your answers are going to be alternating in shaded regions. So you could plug in 2. If you didn't want to do a decimal, you could plug 2 in and you'd see that it's true. See, 2 would be up here on this curve, which is definitely above. So you would find 2 to be true. This would be false, this would be true, and the other side would be false because it alternates, as you can look at the graph and see. If you don't see it from the graph, test a number. All right, interval notation. So we have -1 to 0, union 1 to infinity. What do you think?
I think it's pretty easy,
Not bad?
and I don't think we need to go any more in depth into it.
I am going to give you a study sheet to fill in for the exam. I am going to give it to you. I need to give it to y'all tomorrow.
Wow,
Somebody
today.
help. What's even Thursday?
Oh, yeah.
Right. What? Oh, let me.
Jeez.
So this last problem right here, and you can always come back to this if you want. If you write a little bit slower than what I'm going to write. It's the same technique as we had earlier where we need everything to one side.
That is the center all the points
Notice I just shifted
around
everything to one
the
side.
center point,
And the idea is,
and
where
they're
is
equal
the
to
graph
and I want you to draw
less than or equal to the x-axis?
around this to show that there's
But this particular problem is testing whether you can hang with ugly numbers. Because the numbers are ugly.
Circle.
You would have to actually
draw
rely on the
dot
graph
and gain
calculator.
that center point. So this is circle A.
You have to go to y equals, type it in, go to the,
Now we're gonna
the
jump
graph.
down to
You'd have to use
where it
the second
says
calc,
radius.
finding your zeros. They
may
are
or may
ugly,
not
only one of them's
remember
pretty.
That a
So,
radius is
Here's what it looks like in terms of the
the
sketch.
edge of the circle.
It's,
I do want to introduce a new word.
it comes down a little and then
It
up,
looks weird.
down more.
It looks like I spelled it wrong. I did not. It is called radii. Radius means one radius. Radii means
So,
Just
on the
Holcombe.
graphing calculator,
Your video is playing.
when we are talking about a radius.
did you do that? Is that silly?
Wait, I don't get it. I don't get it.
It's
Marty
just
just thinks everything is
that I'm talking while I'm talking. Anyways, when you go to the graphing calculator, you would type it in y equals. You would do, if you need the reminders, second calc, what is it? Zeros. And then it's going to ask you 3 questions. Meaning, like, okay, put the cursor to the left bound of the 0, to the right of the 0, and then on the 0. So you would have to do this how many times, y'all?
3,
4. You got one here, 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 and here. You would have to do this 4 times. So this would be one of those problems where you want to sketch the graph so you can keep track of, like, your zeros along the way. You would find the following zeros. This is -1. That's the only pretty one. This one right here is 0.586. This is 0.667. And this is 3.414. So I didn't just pull those numbers out of thin air. I would use the graphic calculator, it would tell me, and then I would plot them on my picture. Then to answer the question, I'd go back up here and remind myself of what the simple technique was. Where is the graph below the x-axis? Below would be here and here, right? In terms of answering the question, that would be from these x-intercepts and these. So you do have two shaded sections. You would have two intervals. You do have or equal to, so it's closed. So your answer would look like this. So the point of that question is, can you work with a graph that has ugly zeros? And yes, you can. You just go to the calculator and let the calculator do the work. Just don't lose focus on like what the overall question is asking, which is where is the graph below the x-axis? That's all of 4-6. I had a note to show you number 8 in the homework. Let's save it for tomorrow. So make a note to yourself. You know, you can try 8, but if you don't get it, skip it. The deal with 8 is the quadratic, I think it's quadratic, is sitting on the x-axis. We've not had that happen yet. All of ours have just crossed it, right? Well, if it's sitting on it, then it's either entirely above or entirely below, depending on where it is. So you just have to check your sections. But I will save that for second flex tomorrow. With me? All right. So far we're still doing really good. We've got 4-5. Last year, let me change the video.